As I said at the end of the previous webinar, and it was just an introduction about payouts and how to structure them, it is very important that the payout is correctly structured so that the strategy becomes systematic. What do we mean by systematic? We mean that it is going to run in the future on new data, basically. So there are a few things to keep in mind. First of all, I wanted to highlight that there is a benchmark. You know, when you read the rules, you saw that one of the criteria for your ranking is the information ratio, and the information ratio is a ratio that uses a benchmark. Okay, so we will compare your results versus a benchmark, and the benchmark for this competition is the Equally-Weighted S&P 500 index. It's not very complicated to understand what it means. It's just an equal weight between all S&P members. Okay, that's different from the regular S&P, which is market cap weighted. So this is important to understand. And as I say here, you need to know what the benchmark is, because at the end of the day you need to beat it. So you need to understand how it's constructed, and you also need to understand how it behaves. And what are its strengths and weaknesses, so that you can do better. That's important to analyze. So our first step here is going to be to replicate an equal weight for just to get a feel about what it's doing, and then we'll move on to a more custom payout that is different from equal weight. I also wanted to highlight another important point that I've talked about briefly in the last video, and it was about making sure that when you do that, when you create your strategy, when you replicate your benchmark, then you use information only in the past, not in the future, and that you make sure that the information you are using expands as you go along. We will talk about this in the second part of the coding exercise we're going to show, but that's important. We'll come back to that. Let's start with going to the Jupyter Lab and see how we can replicate the benchmark first. So I have prepared this notebook here. As usual, I'm going to load the library. Let me just get the font a bit better, a bit bigger, so that it's readable. I'm also going to follow this. Here we go. The library, I'm going to run everything again so that we're sure that it's fresh. So as usual, just import the quantitative library so that you can work with it. For convenience reason, I am going to use the star import after that in order to have a more convenient way to call functions. So the loading is coming through. Let's just wait for it to finish. All right, now I'm just importing the data package for convenience. As I said, anything in the data package will now, because I'm importing star, I will get all the functions directly callable, which is quite nice. Just as a reminder, if you want to know what's in the data package, you go in the QLib, and here it's all organized by packages, and the data package is all these functions here. So I can now call them directly from my environment. I wanted to just highlight a few things that we have improved over the past few days, especially to help you to make inclusion matrices. So to determine if a stock or a series of stock is part of the S&P, because that's one of the requirements. We've improved the get ticker function to get you the appropriate list. This function here, get GICS description, is just describing the meaning of each sector. If you don't know, again, if you don't know what a function does, either you go to the QLib to check the documentation. So now I can go there, get GICS description, you can view it, and from there you will have the documentation. Here it says that it provides a map for the global industry classification standards. Okay, so we're going to just see in the first few steps of this notebook how to separate data and check data by sector. If you want directly from the lab whilst you're coding, you can also have this sort of nice looking docstring, which helps you know how to call the function and what are the arguments that are provided. So here, this is my GICS. I'm not sure I've run it. Here it is. So I see there are a few levels: sector, industry group, industry, and sub-industries. What I'm going to do is just look at a sector called financials. So the sector is here; it's the highest level, and I'm just going to take all the financials. So I'm just going to run this and get the list of all financial stocks. That's it. That's financials here, but you see there are many industry groups within financials, banks that have different financials, for example, but you have other ones. And then you have also industry, which is even more granular, and you can dig down like this. Now that we have the view, let's say, like the data frame view of financials, I'm just going to, I'm not too sure what's happening here. Let me just make sure that that I just overwrite the changes. That should be good. And now that we have the list of financials, I'm just going to take the names, basically, of the industry that I am interested in here, all this list of industries. The reason I do that is because we'll see in a minute the ticker function allows you to use the industry argument. So if I just take all the industry, I just take them unique values and put them into a list, and then I call get ticker S&P with the industry being all the lists that constitutes financials, and then I get the ticker from that. So again, if you don't know how get tickers work, you can see that get tickers here receives either tickers or industry code or industry. Here I'm using industry, and if you scroll down, you can see that the industry here is going to subset the ticker data frame by an industry. So here I've given it a list of industries, so all the industries within financials are going to be subset, and then I take the tickers, the unique tickers, and I put it into a list. So the reason why I'm doing all that is to have one dimension, financials, just one sector, and then I wanted to have a bit of exploration of all the data that is within that sector. To do that, we are going to use an object that we have designed. It's called data features. Obviously I haven't run this, so this is not going to work. But data features, basically, again, if you don't know what it is and how it works, I suggest that you do look into the signature and the docstring. The way I am popping that up from the lab is when you are inside the function call, basically, you do Shift Tab here, and you can directly read the docstring as you are coding or typing. Obviously, here the process to get that would be just to look for data features in here, and you will have the same the same documentation appearing here, and you can look at the wiki. You have a version in R and a version in Python. So here I am willing to see the version in Python, here in Python, and see how it works. Okay, so everything is described in there. So basically, what does it do? It's an object to create the data features. So basically, the data feature object contains all relevant information to retrieve and process data. So I'm going to use that basically to say I want all these tickers that are in the financial sector basically, and I want all fields, OHLC and BB Live. I haven't put volumes, but you could put volumes if you want. And then there is a new one here, a method called load. Again, what does it do? Hop. Here, loads data feature data. Okay, so basically here I'm creating this object, data features, that is going to have all these tickers and all these fields, and here I'm loading the data. So once I have that, basically my object, let me just show you, is a data feature object that has a parameter called PXS, and basically this parameter is the prices for all these tickers and all these fields. And yeah, here we go. So you see you have all prices at all dates for these tickers and these fields. And as I've run it already, I've done load. You have already, by doing this, called all data that you wanted from the database. So everything is stored inside the DTF. So now you can start manipulating all this data. For example, we have a plot method in the data feature. If I go there, method, I have a plot method which allows you to apply filters on the data and plot them. So if you just do that, I'm saying I want to plot, and the tickers here is allowing me to apply a filter to my data features, and I want just the insurance industry. So as I said, we have grouped all industries within the financial sector, and here I'm looking at one in particular, which is insurance. I'm getting all the tickers in the insurance industry, and then I'm passing that in to the tickers argument within the plot method, and that is directly subsetting, so it's giving me a view, like a reduced view of the relevant things I wanted. And I've also reduced my universe just to BB Live. Again, remember here I had open price, high price, low price, close price, BB Live for each ticker. Here I'm just saying no, I want the BB Live. And I can directly plot all this into one single chart. By default, if you look into the documentation of plot here, you will see that there is an argument called Rebase, and by default it's true. What does Rebase do? Whether to rebase the time series to its first valid value. Here I'm rebasing all the time series to the first valid value they have. So that's what it's doing. Why am I showing you all this? Is because now you can basically use this data feature class, or this data feature object, in order to load all the data you need within it, and then decide to use just a selected subset of this whole data. I'm going to show you that in a payout. So this is my payout. I'm going to replicate the equally-weighted S&P 500, and here you can see that my first argument is actually a data features object. It doesn't say it, but this is how I have constructed the payout function. So in here I am going to pass it on a feature, and I've put also an industry argument, and then what it's going to do is going to get an inclusion matrix. How do we do that? We call the getTickers S&P function, and apparently that's returning an inclusion matrix. And then from that inclusion matrix I'm just going to get the weights. Obviously that's the equal weight S&P 500, so I just need to divide all included tickers by the number of tickers that are in the index. So that's quite interesting, because now with these 2-3 lines of code, I can have my benchmark. I can replicate the benchmark. So let's just take a deeper look at what this here does really, because it looks interesting that it can return an inclusion matrix. So if we indeed look at this and give it the tickers that are, remember we have already the variable called tickers, and we use this argument as price equal true. We'll probably modify the name of the argument because it's a bit confusing, but we will return a matrix basically of included stocks. So let's take a look at it. That is going basically to tell us in time. So on the rows it's going to be it's going to be dates, and in columns it's going to be all tickers. Basically it's going to tell us if it's included in the S&P or not. So this is what I showed in the previous webinar, and that one of the tasks was for you to create that. We have decided to package it into that get tickers function so that it's easier to create that filter, that inclusion filter in your payout. So now you can directly use that and you get the matrix back. Remember, you need to put that argument here in order to have this this thing. Obviously, here I've done it for the whole tickers here, but you could decide to use here you have more filters if you want, so you can choose to set an industry. Here I'm just going to try and see what the insurance industry is, and that is going to give back the inclusion matrix only for this industry basically. Okay, so that's a nice way to get that matrix quite quickly, and that will allow you to filter out tickers within your payout. I'm just going to get rid of that. So the first line here is just basically give me the matrix of what tickers are included in the S&P throughout the backtest basically, and then well, if it's a 1, then just basically divide by the number of members of the S&P at that date. So that's pretty much it. You don't need to do much more in order to get what you want. So I'm just going to rerun ticker because originally we had subsetted it. Now we are going to use all tickers. Again, I'm using data feature because it's a nice way to have everything packaged within only one object. And then I'm going to use the portfolio pipeline to backtest it. Again, let me just run that. Again, you can construct a portfolio with all the tickers. Here, I'm just taking the whole tickers across the whole universe. And then you apply the payout, but I'm just going to explain this line because it's very important. You apply the payout, which is equal weight S&P 500 select payout. This is this one. And then I'm passing in an argument here, df. df is here. I've created my data features with the whole universe, and what it means is that basically within portfolio here, or within your payout function, which is quite the same, you can pass in a features object as a first argument, because as we saw, and let's just double check that, df.xs, I need to basically load that. So loading just request all data within the universe of tickers that are included in data features, and then I will just display what it looks like. Here it's taking probably 30 seconds because the whole universe, the whole tickers are included. Here we go. I have the end. So all tickers here, and when I load, I create this prices basically argument, which is storing all the time series of all tickers. So that's when I do that, everything is in the object. I don't need to call it anymore, and you can manipulate directly from the object what you have to do. By default, see, I haven't called here. I haven't passed on fields in data feature. See, the fields, I left it at default, and the default field is the BB Live prices, so the adjusted prices here. So this is why I am able to basically use these data features in the payout, is because the data feature allows me to have this series of prices through it. So basically that works. That's compliant with the fact that a payout should start, the first argument should be the data that you're going to use to compute your allocations. And this is pretty much it for this pipeline. Let's get rid of that, and we can then backtest the portfolio and see the results. We are going to see, so this, some people have noticed there is this line here. It's not a blocking line, meaning it's just for your information that a few of the weights within your payout are not executable because there is a non-trading day. So what we do is just we push them forward to make them executable. But this is just for informational. It's not blocking, so it's not a problem if you have a message saying that some days were closed, because we are pushing your weights one day forward so that we can actually trade them. Here you see the metrics of your portfolio with the portfolio total return, and as there are so many assets in the portfolio, we reduce these graphs to only the top 5 and bottom 5 assets by Sharpe ratio within your selection. As you see, at first here, that's an interesting graph with the weights of the portfolio. At first, you could see that these blue weights were included, but then they stopped being included. So they drop out from your payout. Same here with the gray, they were included and then they stopped being included. So it means that our inclusion matrix work. So that's pretty good news. All right, so that's pretty basic, let's say, but it's important to understand the metrics and what you need to beat. 9%, you need to beat that in order to have a strategy that works. And then from that, you can start looking at adding more complexity to your payout. Just notice here in the payout that I have put industry. So what I could do here is when I build my portfolio here, I could do industry equal insurance. Okay. And then rerun all this in order to get an equal weight, but only across that industry. Basically, that should give you basically a way to check if there were industries that perform better than others. Obviously there are, and if you need to overweight some industries versus other industries, or it's going to allow you to have what's called sub-indices or sectorial indices of the S&P, and to try playing with that, start playing with that. Where am I? Yeah. So let's just run the back test for the insurance industry, and then we move on to having a more customized or custom payout. Okay, so here the industry looks like it's not good. It's not a good result, because it has a very large drawdown and it returns less less annually than if you diversify with all sectors. So you can play with that and try to check what happens to sector and start incorporating this information into your payout.